Hey everyone, welcome back to the channel. Today we're going to talk about a really powerful feature in AWS called Auto Scaling. This is an essential tool for anyone managing cloud infrastructure, and it addresses a key challenge that used to plague on-premises IT setups: scaling resources to meet demand efficiently. In the old days, when everything was running on premises, you had to design your infrastructure with peak load provisioning in mind. That meant estimating the maximum load your application might need, even though it was really hard to predict demand accurately. Imagine having to guess what kind of traffic your app would face over a period of time. Would it be a trickle, or would you suddenly be swamped with users? Because you couldn't afford to run out of compute or storage, the safest bet was to provision more than you needed. But the downside? A lot of resources sat idle, leading to wasted capacity and higher costs. Thankfully, with AWS, those days are behind us. AWS Auto Scaling changes the game by automatically adjusting resources to meet your application needs. You no longer need to guess or over-provision. Instead, Auto Scaling monitors your application and scales them based on demand, ensuring you're only using what you need, saving you both time and money. AWS Auto Scaling enables you to provision just the right amount of resource capacity when you need it. As demand increases, the service automatically provisions new infrastructure resources, ensuring your application has the compute power, storage, or other services it needs to handle traffic. And the best part? As demand drops, Auto Scaling terminates unnecessary capacity, saving you on costs and ensuring you're not paying for resources you're not using. This dynamic scaling keeps your infrastructure efficient, cost-effective, and responsive without the need for manual intervention. In this video, I'll be giving you a detailed introduction to the AWS Auto Scaling service, its core features, and how it works behind the scenes. Stick around, because I'll also walk you through how to configure the service in a live demo lab. Let's get started with this video. Okay, so what I want to do is get started with a typical use case. Let's imagine that we're looking at the capacity requirements for the finance department for their accounts application of a really large multinational organization. Let's assume that this is the capacity usage pattern over the course of a 7-day period. So it looks like some folks are working Saturdays and Sundays. Obviously, this is a really large organization, and the accounts department seem to be working 7 days a week. But the point is that you will notice that Tuesday tends to be the most busiest day. It seems to be the day that all of the accountants, the accounts assistants, junior accounts assistants, the finance guys, the forecasting folks in the finance department are busy using this application. And on the Tuesday, it's maximum usage. So there's a lot of capacity requirement on the Tuesday. As the week progresses, when we hit at the end of Thursday, Friday, things seem to drop down a little bit, and there isn't that much capacity requirement required over the weekend. The question then becomes, how do we handle capacity provisioning for such an uneven usage pattern? In the old days, when we had on-premises IT infrastructure where you had to actually physically buy infrastructure, you were not able to actually be very dynamic in how you provision capacity. So we opted for the principle of peak load provisioning, which basically means that you have sufficient capacity provisioned to cope with the maximum usage pattern you could experience. So you want to have sufficient available capacity so that you can handle the load on the Tuesday. Even if it meant that as the week progresses and towards the end of the week, you would have a lot of unused capacity, leading to inefficiencies and a lot of wastage in terms of cost and resource utilization. So what's the alternative? Well, there isn't one. I mean, you could under-provision capacity. You could have available capacity that kind of like averages out over the week, so that you have an average utilization and available capacity of a specific amount that will cope with mean usage. But the problem is that on the Tuesday, you're going to get a lot of complaints into the service desk. The accounts application is very sluggish, it's not responding, all that stuff is going to happen, and your finance department is not going to be very productive. AWS comes to the rescue with the auto scaling service, because what that service does is it looks at usage, it looks at load, It monitors metrics using a product called AWS CloudWatch, on how your servers are being consumed and how the capacity is being consumed, and will adjust capacity accordingly. As demand for the application increases, additional capacity will be provisioned to cope with that load. As demand drops towards the end of the week, AWS Auto Scaling will terminate instances no longer required, resulting in more efficient usage of resources and lowering cost. So, ultimately, the AWS Auto Scaling service allows businesses to be far more efficient, consume only what they need and when they need it. Let's take a look at the Auto Scaling service in a bit more detail and discuss its core features next. Now, there are two types of auto scaling services on AWS. The first and most commonly used one that you will encounter is the Amazon EC2 auto scaling service. This basically allows you to automatically scale Amazon EC2 instances, either with a scaling policy or with scheduled scaling. We'll talk about these shortly. With EC2 auto scaling service, the idea is based on you have a set number of EC2 instances, and as the load increases, you can provision additional instances to cope with that load. You can use Amazon CloudWatch. Again, we'll talk about CloudWatch shortly, which will monitor the metrics of those EC2 instances, and based on specific thresholds that you define as alarms, will trigger the launch of additional EC2 instances. Conversely, as the demand drops, CloudWatch will monitor your instances, and if metrics like the CPU utilization on those instances drop, then auto-scaling services will terminate unnecessary instances. In addition to that, we have something called application auto-scaling. Now, there are a vast number of services that offer inbuilt auto-scaling mechanisms for you to use in order to be efficient with your resource capacity provisioning. So for example, we've got Amazon ECS, which is Elastic Container Services, allowing you to deploy Docker containers on the AWS platform. Here again, with the ECS service, you can provision a set number of tasks, but as the load increases, you can have the application auto-scaling service, the ECS service, provision additional tasks to cope with the load. Similarly, you've got DynamoDB. So DynamoDB supports the auto-scaling of read and write capacity for the table and its global secondary indexes. So we've provisioned these write capacity units and read capacity units as shown in the colored boxes, and these can be additionally provisioned as and when demand increases. You also have the Amazon Aurora Cluster auto-scaling component that allows you to essentially scale the replica count. So as the read requirements and the demand for reading from the database increases, the service will automatically provision additional read replicas for your auto-scaling services for your Aurora cluster. Now, in auto-scaling, you need to specify what's known as the minimum capacity, desired capacity, and maximum capacity. These are essentially settings that allow you to define how your auto-scaling group is going to behave in terms of the resource scaling. So if we take a look at an example, you could have a minimum capacity of, say, 2 EC2 instances in your auto-scaling group. This is the minimum number of instances or resources that your auto-scaling group will maintain at all times. Even if demand is low, auto-scaling will never reduce the number of instances below this threshold. This ensures that your application always has at least this level of capacity running, which is important for ensuring availability or handling baseline traffic. You also need to define something called desired capacity. This is actually the target number of instances or resources that auto-scaling group tries to maintain. When auto-scaling group adds or removes instances based on demand, it will attempt to adjust the number of running instances to meet this desired capacity. This capacity is dynamic and changes according to the scaling policies and actual traffic conditions, but it always stays within the limits set between the minimum and the maximum capacity. Finally, you need to define the maximum capacity. Now, this is the upper limit on the number of instances or resources that your auto-scaling group can scale up to. Even if demand spikes significantly higher, auto-scaling will not provision more than the specified maximum capacity. Now, this actually helps you control cost and prevent overscaling beyond what the application can handle or what your budget allows. It also addresses the slight concern that you might have a bug in your application that inadvertently causes auto-scaling to keep repeatedly deploying more instances than is actually required. So it kind of like acts as a barrier for any kind of mishaps or misconfiguration. So as an example, you could have a minimum capacity set to 2, a desired capacity set to 4, and perhaps a maximum capacity set to 8. In this sort of scenario, your auto-scaling group will always run at least 2 instances, even if demand is really low. It will aim to maintain 4 instances under normal conditions, and if demand increases substantially, it will scale up to a maximum of 8 EC2 instances. Okay, let's take a typical example of an auto-scaling architecture and see how we would actually use the service. So here we've got a typical architecture. It's a VPC that comprises of 2 availability zones, 2 subnets, if you will, in that VPC, within which we have deployed a set of 4 EC2 instances using the auto-scaling service. We could consider these 4 instances as being the desired capacity for our auto-scaling group. We want a desired capacity of 4 EC2 instances spread across 2 availability zones. So 2 in availability zone A and 2 in availability zone B. Our users that are accessing this application come via a load balancer. So you can integrate your auto-scaling service with a load balancer so that the load balancer can automatically distribute traffic to any and all EC2 instances in that auto-scaling group. Now, you've covered the load balancer lecture with me earlier, and you will know that the load balancer service does perform health checks against those EC2 instances. If there's any EC2 instances that doesn't respond correctly to the health check, the load balancer disregards it. The auto-scaling service works slightly differently when it comes to health checks and how it functions with the EC2 instances, or how it interacts with the EC2 instances using those health checks. We'll come on to that in a second. But ultimately, this auto-scaling group has deployed 4 EC2 instances and is using CloudWatch metrics to determine the demand, the load, the capacity requirements of the group. We've got few users coming into our website. So what happens is, over a period of time, as those users increase, as the load on our servers increase, we could, for instance, monitor a metric like CPU utilization. And as those users increase, CPU utilization would predominantly start rising. Okay, we could then set an alarm at a particular threshold level. So at a particular metric, say for instance, CPU utilization hitting 80% for about 15 minutes, we could trigger an alarm. The alarm will then call on the auto-scaling group to take some action, because now the average CPU utilization is at 80%. It's bound to degrade performance. Users are potentially going to start complaining, and we want to do something about it. We want auto-scaling to take the necessary action. So here, the auto-scaling service will provision some additional EC2 instances, register them with the load balancer so that the load balancer can also send traffic to that new instance. And hopefully, with that in place, the metric values will start to drop in our CloudWatch monitoring service. Okay, so then hopefully we're now able to deal with this additional influx of traffic. Likewise, the opposite is true. If we start to see a reduction in traffic, then the CloudWatch metrics value will start to drop, and we could set another trigger point to create another alarm that basically says that if CloudWatch monitors the CPU utilization as having dropped below a particular threshold value, maybe say 20%, we could start terminating EC2 instances. Now, in addition to using CloudWatch metrics to define exactly how many instances to provision and how many to terminate, the auto-scaling group service also performs health checks against your EC2 instances. In fact, in this sort of configuration, you've got 2 different services that are performing health checks. So the first is the auto-scaling group itself, which runs something called the EC2 status checks services. This is the actual check to see whether those instances are up and running. Within the EC2 status checks, what auto-scaling does is it's looking to see whether or not those EC2 instances are responding, whether they are responding to ping requests, for example. All the EC2 status checks does is therefore check whether those servers are live and kicking, right? In addition to that, you can also run checks at the load balancer level. So the load balancer can run health checks against your EC2 instances specifically related to the application. What the load balancer can be configured to do is check for a particular function, a particular feature, or a particular response from the application to determine whether the instances should be considered healthy. There's no point in having those EC2 instances up and running if the application itself is dead, right? So using a combination of EC2 instance status checks as well as elastic load balancer checks, you're able to be reassured that A, the servers are up and running, but also the application is responding to customer requests. In this sort of scenario, if the ELB picks up that the application itself is not responding, then it will stop sending traffic to that load balancer. And as discussed previously, load balancers work on this principle alone. If a target is healthy, it will send traffic to that target. If it's not healthy, not responding with healthy responses, like the 200 success code for an HTTP request, then it will just stop sending traffic to it. When it comes to the auto scaling group, however, if it detects that a particular instance is unhealthy, either as a result of its own status checks or the ELB health checks saying that that instance is unhealthy, the auto scaling service will provision a replacement instance and terminate the instance that is unhealthy, maintaining the desired capacity as per our auto scaling group configuration and ensuring that we can continue serving our customers. Okay, so next let's go ahead and do a little bit of a deep dive on the various auto scaling policies. So the first one is manual scaling. Now, manual scaling allows you to manually adjust the number of EC2 instances in your auto scaling group at any given point in time. The process involves literally making manual changes to the instance count or the resource count that you have within your auto scaling group, and it's an alternative to auto scaling, especially if you want to make one-time capacity changes. Next, we have dynamic scaling. Dynamic scaling is going to be based on specific metrics within CloudWatch that you monitor: CPU utilization, network bytes in and out, number of requests to your load balancer, etc., etc. And what happens here is that the auto scaling service will trigger various scaling operations based on alarms that CloudWatch triggers. If CPU utilization hits a particular threshold for a specified period of time, an alarm is triggered, and that alarm is then going to trigger the scaling action. Now, with dynamic scaling, you've got two different options. You've got something called target tracking, okay, which is a bit like a home thermostat where it automatically scales the capacity of your auto scaling group based on a target metric value. This allows the application to maintain optimal performance and cost efficiency without manual intervention. So to give you an example, the way our home thermostat works is that, let's say you set it to 18 degrees, right? And you have a situation where it's getting warmer. Okay, so the house or your flat is heating up a bit, it's getting a bit warmer. What's going to happen is the thermostat's going to stop the heating, it's going to shut the heating down so that the temperature will drop down to 18 degrees. Likewise, it's in the middle of the night, it's getting really cold outside, the house is cooling down, it's getting much colder. The heating is going to kick in so that we can rise the temperature in the house back up to 18 degrees. And so it's that target metric value that we're trying to get to. It's a balance of the amount of heating versus the actual target value that we need to get to. So in the same way, with EC2 instances, you want to maintain, say, for instance, a target value of 30% average CPU utilization across your fleet, because you know for a fact that that gives you optimal performance, both from customer experience, but also to ensure that you don't unnecessarily incur additional charges by having too many instances, just so that you can bring the CPU utilization down to 10%, right? There's no need for that. So target tracking is one dynamic scaling option. The other option is step scaling. Step scaling, or simple scaling, is where you scale a resource based on a set of scaling adjustments that vary based on the size of the alarm breach. So let me give you an example. You could scale out by 10 instances if the alarm metric reaches 60% CPU utilization. You might choose to scale out by 30 instances if the alarm metric reaches 75% CPU utilization, or 40 instances if the alarm metric reaches 85% CPU utilization. Next, we have schedule scaling. So schedule scaling is ideal for seasonal demands and expected demands based on a specific schedule. So an example is, on Wednesday morning, one schedule action increases capacity by increasing the previous set desired capacity of the auto scaling group. And then on Friday evening, another scaling action decreases capacity based on decreasing the previous set desired capacity of the auto scaling group. Finally, we have something called predictive scaling. This is really cutting edge stuff. This essentially uses historical load data to detect daily or weekly patterns in traffic flows. And it uses this information to forecast future capacity needs. So Amazon EC2 Auto Scaling can proactively increase the capacity of your auto scaling group to match anticipated load. Okay, so ultimately this uses machine learning to forecast the predicted scale out and scale in patterns, and the data is obtained from those daily and weekly usage patterns. Now, for predictive scaling to start forecasting future values, the metric must have at least 24 hours of data. After you create this policy, predictive scaling starts analyzing metric data for up to 14 days to identify patterns. It uses this analysis to generate hourly forecast of capacity requirements for the next 48 hours, and the forecast is updated every 6 hours using the latest CloudWatch data. As new data comes in, predictive scaling is able to continuously improve the accuracy of future forecasts. Okay, so next I want to take you through some of the core steps you will need to take in order to set up auto-scaling for EC2. So the first thing you need to do is create something called a launch template. The launch template basically is literally that. It's a template that allows you to define the AMI that you're going to use, the EC2 instance type that you're going to deploy, any EBS volumes you're going to attach, any security groups that need to be associated with the instance profile, which is basically an IAM role that you may need to grant the instance some permissions to, any user data scripts so that when you launch the instance, it can install some applications, or it can update the operating system, whatever you like, key pairs, termination protection, and the list goes on and on. So you've got this template that will basically define exactly how auto-scaling is going to configure your EC2 instances. Once that's in place, you can then go ahead and set up the auto-scaling group. Now, the auto-scaling group comprises of a number of key elements. So you need to define the VPC and the subnets within which you want to deploy your instances. Optionally, you can attach an elastic load balancer and automatically register those instances with the load balancer. You will also need to define all of the health checks. Now, this can be just the EC2 health checks or a combination of EC2 and ELB health checks. And what this essentially means is that you define all of the necessary parameters when a particular instance is considered unhealthy and when it's considered healthy. Finally, you define the actual auto-scaling group. So this is where you do your minimum, your desired, and your maximum capacities, and any scaling policies. So for instance, if you're going with schedule scaling or if you're going with dynamic scaling, then you might also want to consider, whether it's target tracking dynamic scaling or step scaling and so on. Once you've got all of that in place and you launch your auto-scaling service, it then triggers the deployment of your auto-scaling group, deploying your EC2 instances, setting up your auto-scaling group with your designed capacity. So in this example on the screen, we're looking at 4 instances, and then it can scale up to a maximum of 6 instances for your group. Remember, auto-scaling is going to use CloudWatch in the background to monitor whether or not it needs to scale out or scale back in. And also, if any of the instances fail to respond to health checks, auto-scaling will terminate that instance and replace it with a fresh, healthy instance. That pretty much covers all of the theory side of the auto-scaling service for Amazon EC2. Let's jump into the AWS Management Console and actually give you a demonstration on how to configure the auto-scaling service and deploy a website using auto-scaling. Okay, so let's go ahead and get started with doing a hands-on demonstration for our AWS Auto-Scaling service. Now, this is an extended demonstration. We're going to actually be creating an elastic load balancer as well as an auto-scaling group. And the purpose of this is to show you how you integrate the elastic load balancing health check services within your auto-scaling configuration. We'll be taking a look at exactly how you can set up auto-scaling for EC2 instances, defining your min, desired, and max capacities. We'll also take a look at how we can test those health checks. And then finally, we'll take a look at how we can scale out as we increase demand and load on your actual instances. Now, before we actually get into the AWS Management Console, let me show you an architecture diagram about exactly how this is going to be configured. So here we have a basic, simple architecture. We're using a VPC in the AWS cloud. I'm not going to worry about public and private subnets right now. Essentially, these instances are going to be deployed in the public subnets. If you've got access to the VPC we built earlier, which is the IaaS demo VPC, you can go ahead and use that because that's configured already with the necessary security groups, the public subnets, the route tables, and all that stuff. Or you can go ahead and use the default VPC. However, if you do use the default VPC, just be aware that you need to create 2 security groups, one for your load balancer and one for your EC2 instances. So traffic is going to come from the internet, hit the load balancer, and the load balancer will distribute that traffic amongst the targets in the security groups. The auto-scaling service is going to be configured in such a manner so that it registers every new instance it deploys against that load balancer, which is why we first need to create the load balancer and then we'll go ahead and create the auto scaling group. In terms of how we're going to get auto scaling to actually deploy and configure our instances, we're going to be using a standard AMI, standard Linux AMI, and then we're also going to be using a user data script. The script is available to you in the resources section of this video or in the description box below from our GitHub repository. You can copy that script onto your desktop, and then you can use that script to actually set this all up. The script will allow you to basically present a simple web page, nothing fancy, but it does have the ability to show you which instance you're looking at, or rather more precisely, which availability zone that instance is sitting in. So you can take a look at that as well. Once you have deployed your auto scaling group using the AMI and the user data script, which will be part of the launch configuration, auto scaling will go ahead and deploy your EC2 instances based on your group specifications and scaling policy. As I mentioned earlier, we'll go ahead and do some tests against the health checks, and then subsequently we'll also take a look at how CloudWatch is going to be incorporated in order to manage the scale out. As part of the auto scaling configuration, when you're defining the group size, we will also be configuring a target tracking scaling policy. And we'll set the target tracking scaling policy to 40%, which will allow us to ensure that we maintain a base level of 40%. Essentially, we'll do a bit of a test to see that if we cross that 40% mark in terms of CPU load, what's exactly going to happen to our instances. We're expecting auto scaling to deploy additional instances in order to bring that CPU metric level down. All right, so that's enough of all of the architecture reference diagrams there. Let's jump onto the AWS Management Console and do this. Okay, so we're going to go into the AWS Management Console, and the first thing we're going to do is set up that load balancer. Okay, so let's just go into the AWS Management Console. Okay, so here we are in my AWS Management Console. This is a development account. This is the account in which I've created a VPC that basically has two public subnets across two availability zones. And I'll show you the VPCs first before we actually move on to the load balancers. So you should have a VPC configured with a minimum of two public subnets. Okay. And if you take a look at it, I've called mine the IaaS test VPC, right? And essentially this VPC, if we take a look at the resource map, comprises of two public subnets, public subnet 1, public subnet 2. They're connected to a public route table. That public route table essentially has a target to the outside world using the IaaS test VPC internet gateway. Okay, so that's essentially the setup there. Okay, so with this VPC in place, let me just take you now to the security groups. Now in the security groups, you're going to need two security groups. If you've got this done already from previous sessions, then fantastic. Otherwise, you need to make sure that you have two security groups created. First one is going to be for your load balancer. That's the one that's going to be responsible for allowing traffic to hit the load balancer. And in this security group, you want to create an inbound rule, okay, with the type of HTTP, so that's port 80, and that's coming from the entire planet, okay, from the external networks. Then you want to create a second security group. We're calling this one Web Server SG. Now this one has two inbound rules. The first one is the SSH inbound rule. Okay, this allows us to remotely connect to the server so we can do any kind of admin work, and we will need access to this. So you need to create an SSH rule, and I've set this up to, the entire planet, but that's probably not best practice. You can restrict it to using it to just my IP, in which case it will pick up your public IP address and ensure that only you can connect to it over SSH. The HTTP traffic, however, the source of that traffic is this other security group. This is in fact the ALB security group we created moments ago, or that I showed you moments ago. So what we're essentially saying here is that all web traffic that goes to any instance connected to the web server SG will only be from the application load balancer, okay? Because the application load balancer will be attached to this security group, the SG EF9. So if I take you to security group, where is it? Here it is, EF9. Okay, so that's the security group. That's the source of that traffic to any instance connected to the web server SG. Right, that is your basic infrastructure setup. That's essentially your VPC and your subnets and stuff like that. Just to show you again the two subnets. Public subnet 1 is in availability zone 1A, public subnet 2 is in availability zone 1B. So we are making sure that we can offer high availability, resilience, and that sort of failover capability there. All that in place, let's go ahead and set up our load balancer. So your load balancer is going to be in the EC2 section. So in the EC2 dashboard, I'm going to bring that up. Okay. And we're going to set up an application load balancer. Now to set up an application load balancer, we've got a video that we've done on this before. You should have set that up or given that a shot. But if you did terminate your application load balancers in order to save on cost, then we'll just do it one more time as part of this exercise. So I'm going to walk you through that. Your application load balancer requires you to configure a target group. So we'll start by creating a target group. And we'll say create a target group. And your targets can either be instances, IP addresses, Lambda functions, or another application load balancer. So in this case, it's going to be instances that we're going to be targeting. Give it a name. I'm going to call this one IaaS demo TG for target group. We're looking at the HTTP protocol. Okay. Because we're using application load balancers, you can only use HTTP and HTTPS anyway. We don't have any certificates. We don't have any SSL, so we'll just stick with HTTP. The IP address type is IPv4. You need to make sure you put the target group in the right VPC. So that's our IaaS test VPC. Protocol can stay at HTTP1. That's fine. Health checks. You want to make sure that we are setting the protocol to HTTP. And as part of deploying our EC2 instances, we will be creating something called a health check file. It's a basic HTML file. It's the file that your load balancer is going to check and see if it can get a response from before it determines that this instance is healthy. And the name of the file is health.html. So you want to make sure you put a slash health.html. Scroll further down, click next. And you get to the stage where it says register targets. Now we don't have any targets, okay, because we haven't obviously set up auto scaling yet. So that's fine. We'll add the targets later. So create target group. And that's our target group created. Okay, so currently there are no instances registered to those targets. Next, we're going to go down and create the actual load balancer. So here's the load balancer. So click create a load balancer. So we're creating an application load balancer. Let's give this load balancer a name. So that's IaaS demo ALB for application load balancer. The scheme is internet facing because this load balancer sits at the edge, okay, at the edge of your VPC, and it's going to be facing the internet. It's going to accept traffic from the internet. The IP address type is going to be IPv4. Your network configuration requires you to put the load balancer in the right VPC. So that's the IaaS test VPC, and specifically in the public subnets. So we're going to put it across AZ1A and AZ1B. And that's going to be public subnet 1 and public subnet 2, where the load balancer nodes will be deployed transparently by AWS. Now the security groups, so let's get rid of this default one. So you will recall that we've got the ALB SG security group. So that's where that comes in. And in terms of the listeners and the routing, so we're going to listen on port 80 and we're going to forward that traffic to our target group, which we created moments earlier. That's your summary, and we're going to go ahead and click create a load balancer. Okay, so that's the load balancer up and running. It's currently provisioning, and in a short while it will be active. Okay, so now that we have our load balancer up and running, we can move on to the next stage, which is to set up our auto scaling services. Let's do that next. Now, in order to actually deploy your auto scaling group, there's a two-step process to follow. The first thing you need to do is to create a launch template, which defines exactly how that instance is going to be configured, which security group you're going to attach to it, any user data scripts, the AMI you're going to use, all of that stuff is going to go in the template. Once you've done that, then we can configure the auto scaling group itself and any scaling policies. So step one, from the left-hand menu, go into launch templates and let's create a new launch template. So here we're going to give it a name. Okay, IaaS demo LT for launch template. I'm just going to copy and paste that in here as well. And then you need to select an AMI. I'm going to go with the Quick Start Amazon Linux AMI. We're going to go with Amazon Linux 2023 AMI as the standard AMI configuration. I'm also going to select T2 Micro, so that's going to be our instance type. And we know that that comes under free tier. I'm not going to bother with setting up key pairs because we're going to use the EC2 Connect feature to connect to our server rather than, our locally installed PuTTY or terminal window. So we don't need key pairs for that. If you are using a local SSH client, then you will need to set up key pairs. Under network settings, I'm going to leave the subnets as do not include in launch template because when we come to the auto scaling group, we'll configure that there. And for the security group, I'm going to define the web service security group, which, as you know, will accept traffic on port 80 from the load balancer and port 22 from the internet. Expand network configuration. Now, what we need to actually ensure that our servers are going to get public IP address. There's more than one way of doing this. You could actually go into the VPC console and ensure that the subnets are configured to automatically assign public IP to any instances deployed in those subnets, or you can configure a network interface here with a public subnet. Personally, I would do the first option, which is where you actually set this up in the public subnet. So let me show you where that is. Let's just go into the VPC console very quickly. Okay. And what we're basically saying is that if I'm going to deploy an instance in the public subnet, well, then by definition, let's give it a public IP address. So we go to subnets and we've got public subnet. There we go, public subnet 1. And basically, if we go to action, edit subnet settings, then what you can do is you can enable this tick box that says enable auto assign public IP address for any instances deployed in the subnet. So just save that. And let's do that again with the other one. So that one as well. Action, edit subnet settings, enable auto assign public IP address for any new primary network interface of an instance in this subnet. And save that as well. Okay, so that is there. So what that means is that now when I deploy instances into the public subnets, they're going to automatically get public IP address and I don't need to do some additional configuration here. In the real world, all of your web server instances can actually sit in private subnets and be serviced by the load balancer sitting in the public subnet. So that's a far more secure configuration. And you can make that even more secure when you start thinking about network load balancers, VPC private links, API gateways. That's all stuff for another video. The point is, my instances will need public IP addresses because they're being deployed in the public subnet. So that configuration in the subnet level to automatically assign those public IP addresses there will take care of that. So next, let's scroll down and we've got storage. We'll leave that as it is. Resources, nothing to worry about there. Let's expand the advanced details section. Now here, ideally you want to attach any kind of IAM roles that your instances might need. So that goes in here. You can also configure any of these behavior patterns like termination protection, stop, shutdown behavior, and all of that stuff as well. I'm going to scroll all the way down and come to the user data section, which is where our script is going to go. Now, the script is available to you in our GitHub repository, link of which is in the description box below or in the resources section of this video. Let me bring up the script and show you what it does. Okay, here's our script. So it's a very simple script. All it does is it updates the operating system, installs the Apache services, configure some permission for the EC2 user. This portion of it basically grabs the information from the server's metadata as to which availability zone the server has been deployed in, and then saves it as a variable called instance AZ. We're going to use this information. In the index.html file, a little bit of background configuration there. We're basically saying that this instance is located in availability zone, and then we're calling that variable. So we know which instance we're talking about, which availability zone it's in. Okay, so just to kind of like give it a little bit of dynamism there, that's what this page does. There's also another file that's created by the script called the health.html file. If you recall, when we set up the load balancer, we had configured the health checks to look for this file. So if this file doesn't exist on the server, health checks are going to fail, right? We don't want that to happen. Otherwise, autoscaling is going to get a little bit confused and start deploying servers again and again and again and end up in a loop. We don't want that to happen. So we need to make sure that there's a file called help.html there. Right, let's grab all of that, copy paste job. Okay, so that is taken care of. Let's just scroll down a little bit, make sure it's all fine. And then I'm going to click create launch template. That's your launch template created. Next step, let's go ahead and create the auto scaling group. Okay, so from the left-hand menu, let's go down to auto scaling group and click create an auto scaling group. Okay, so we'll give it a name. Okay, IAS demo-ASG. And then we're going to select the launch template. That's going to bring up the launch template details, and then you're going to click next. Okay, then the network. Now you're going to put this in the IAS test VPC. If you're using default VPC, bear in mind of those security groups and those subnets and stuff like that. I'm putting it in my IAS test VPC, and I am associating it with the public subnet 1 and public subnet 2. So I want an auto scaling group to deploy across these two subnets evenly. An auto scaling group is really clever. It will actually ensure that it's evenly distributing the instances across the groups. Click next. Now, load balancing, this is where you're going to attach that load balancer we created earlier. Okay, you can choose to have no load balancers. You can create a load balancer from scratch here, but we've got an existing one with all the health checks configured, so we're going to choose that. And here you have to define the target group of that load balancer. So this was the IAS demo TG target group. Okay, so next, just scroll a bit further down. I'm not going to bother with the lattice integration in this video. We can take a look at that in another video. For now, let's just move on to the health checks. So by default, it's going to do the EC2 health checks anyway, but we want to turn on the load balancer health checks as well, because the load balancer is actually looking for an application related file, health.html in this case, before it says that, you know, this server is healthy. It's waiting for responses from that HTML file. It's looking at the application layer rather than just the server layer. Okay, scroll a bit further down. We'll ignore the additional settings for now. Click next. And this is where you define your group size. So our desired size is going to be 2. Our minimum, I'll set that to 2 as well, but I'll set the maximum to 4. Okay, so I would like to scale out to 4 instances as a maximum. If I'm going to set up a scaling capability for my auto scaling group, I need to obviously define a scaling policy. Now, you can deploy this with no scaling policy and go back in and reconfigure this with step scaling and simple scaling. We can just set up the target tracking scaling policy here as well. So we'll enable that target tracking scaling policy, where we will choose a average CPU utilization as our metric type. And the value, I'm just going to set that to 30%. Okay, so if it's going above 30%, I feel based on past experiences and tests and stuff that, you know, performance is going to be somewhat degraded. Okay, or it might be 60% or 70%, whatever your test results come back with. Okay. Moving down further, this is the instance maintenance policy. Now, we're not going to bother with this in this particular lab, but just to give you a quick overview, you have different policies that you can choose from a maintenance perspective. You can prioritize availability. So if you enable this option, what it does is it launches the new instances, waits for them to come online and be ready to serve customers before terminating other instances. Whereas the control cost policy, that basically will terminate and launch instances at the same time. And you may end up having a situation where you have less than the desired number of capacity for a given period of time, small period of time, and that may temporarily reduce availability. So the choice is yours based on your use case. Okay, click next. Notifications, we'll ignore that for now. And tags, I'm going to tag my servers. I'm going to call this the auto scaling servers. Okay, servers, there you go. And then click next. And that's all my configuration in place. I'm going to go down and click create auto scaling group. And that's going to start configuring the auto scaling group service and then working towards deploying 2 EC2 instances to match my desired capacity. Right, I'm going to post a video over here and then come back once it's up and running. Okay, so as you can see, we've deployed 2 instances. We're meeting our desired capacity. Our minimum capacity is 2, our maximum capacity is 4. Let's take a look at the instances for a second. So if you go up all the way to instances, you will see that in fact, I have 2 instances deployed there. Okay, so those are my 2 instances. And if we scroll down further and go to the load balancers, this is where the load balancer is sending traffic to our instances. So we can actually go into the load balancer. So I can just copy that DNS name and then open up in another browser tab. Okay, so that is my website up and running. This instance is located in an availability zone, and using that variable, using the metadata information, it's pulled out that it's looking at a server in the availability zone 1A. If we do a refresh of that page a few times, there you go. We're now looking at the other server in availability zone 1B, and so on. So our servers are up and running, load balancing is working, and obviously the auto scaling group has deployed our servers. Let's go back to our EC2 instances. Let's scroll all the way to the top. If I go to one of these instances, I can actually connect into it, and I'll use the EC2 instance connect feature. Okay, this requires just the fact that port 22 is open, but I don't need to use an SSH client. Okay, so I'm going to click connect. That's going to take me using the web console to the actual server. There it is. And then I can just log in. So if I now go to the HTML directory, you will notice that I've got my 2 files in there. The indexed file, which is the one that we saw on the web page, there it is. And then obviously there's that help.html file. And if I were to go back to instances very quickly to my EC2 console and go down to target groups and click on target groups, you will see in fact under health checks that I've got 2 healthy servers because it's able to connect to that file. Okay, the help.html file is there, and it's getting the 200 success response code and therefore marking the server as healthy. So to test this out, if we go back to the EC2 management console, and let's say I remove the health.html file. So rm health.html file, and yes, I want to remove that. And now if I click ls, right, the file's gone. So the health check is not going to be able to see that file anymore on this particular instance. And so that's going to then cause an issue because the health check is then going to say, hang on, I'm not getting a response from the server, and therefore I'm going to mark it as unhealthy. So we can take a look at that in action. If we go in here very quickly and click on targets, okay, and it takes a little bit of time to kick in because it's obviously it needs to monitor it. And I'll just refresh this page. And there you go. It's found that this particular server is unhealthy. So that's the one that we were connected to. That is, in fact, not responding with the health checks anymore. Okay, so what happens next? Well, our servers are down by 1. Okay, and as per our auto scaling group configuration, we want a desired capacity of 2. So if we go into our auto scaling group and click on activity, currently you're just seeing that it's launched 2 successful instances, but now auto scaling is going to get triggered by the load balancer within a space of a few seconds to maybe a couple of minutes, but it is going to find out that, okay, that server is no longer responding. Auto scaling is going to kick in. It's going to launch a replacement instance and then terminate that instance as well. That's just sitting there because that server is no longer responding to clients. So if I click refresh on this page, and it takes a few seconds to a minute or so. Okay, and there you go. There's some action there. So connection draining progress, so terminating EC2 instance. So that's the instance that was obviously not responding to the health check. Okay, so that is taken out of service in response to an ELB system health check failure, and it's launching a new replacement instance in response to an healthy instance needed to be replaced. So if we scroll up and look at instances, and if I refresh this page, you will see what is happening. And so it's very clear what has transpired. Another instance has been launched, and obviously the instance that failed the health checks is shutting down. If I refresh that page again, that instance has now been terminated, and we're back to our minimum, or rather desired, 2 EC2 instances in the fleet. If we scroll down again to the auto scaling group, and if we take a look at the actual ASG and click on monitoring, and then click on EC2, you will see in fact that the CPU percentage utilization, it had risen a little bit there, okay, and then it's dropped again. Okay, now at this point in time, what you have seen obviously is the fact that our auto scaling group has responded to ELB health checks, and when ELB identifies a server as unhealthy, auto scaling kicks in, replaces it with another server using the launch template to build out that server. Next, what I want to show you is how we can scale out given the fact that we're increasing load on the server. So let's do that next. Okay, so what we're going to do now is run a stress test on one of our instances that is part of the auto scaling group. So I'm going to grab this particular instance and we're going to connect to it. Okay, and the purpose of this is to basically run a bit of stress on the server so that we can increase the average CPU utilization, and then hopefully then we will see how the scale out process happens. So this is the EC2 connect service. We can now connect to the server. So we're connecting to one of our servers. Okay, and I'm just going to go in as root, and then basically I want to install yum install stress. So it's a piece of software that, spell that correctly. It's a piece of software that will actually help you run some stress test. Okay, so that installs the software. That's completed. Fantastic. I'm going to clear the screen. And then you just need to run a command called stress -c and 4 for 4 CPUs. At this point in time, on this server, we're running a stress test and we're using 4 CPUs, and that's going to bump up that CPU utilization. It takes a little bit of time, about a couple of minutes, but we should start seeing some reaction. Okay, so if I go now to auto scaling group and go into the auto scaling ASG, and if we click on monitoring and then click on EC2, okay, that's going to start affecting our server. So currently it's still really low, okay, because it takes a bit of time for it to reflect based on the metrics and the timeline to be captured. Okay, so I'm just going to pause the video over here and then come back to it once we have some data. Okay, so we've now got some data. I've just done a refresh of the page and you can see our CPU utilization is gone up. Let's go into the actual activity and take a look at what's happening. And actually you will see that in fact, auto scaling is launching another instance, and it started in response to the difference between the desired and actual capacity, increasing the capacity from 2 to 3. And the reason why it's done that is because we've entered into an alarm state. Let me show you how that is. So you can go into CloudWatch, okay? And I'll take you to CloudWatch really quickly. And in CloudWatch, we have an alarm, okay? An alarm has been triggered because our CPU utilization is greater than 30% for 3 data points within a 3-minute period. There are actually 2 alarms that AWS Auto Scaling will create. These are configurable, but the default creation when we set up that 30% value was that we would go into an alarm state if CPU utilization is greater than 30% for 3 data points within 3 minutes. Should that happen, in which in this case it has, then it's going to trigger an alarm. There is another alarm which is currently in the OK state. This alarm is when we define the threshold value as being low and therefore we need to scale back. Okay, so in this situation, if the CPU utilization drops below 21% for 15 data points within 15 minutes, then we'll start terminating servers. Okay, but right now we have a situation where we've crossed that 30% threshold. We need to maintain our target tracking policy. Okay, so auto scaling has gone ahead and launched another instance. So let's just see what's happening there. So it's launching the second one. So if we climb up to instances, if I do a refresh there as well, you will see that in fact this is the server that is currently initializing. Now I'm still running my stress test on the other server. Where did it go? There it is. That is still happening. Okay, so that server is still having a lot of stress. So really it's not responding to anyone at this point in time. So we have a situation now. We're going to bring up this server. Okay, that has passed its status check. So it's going to be part of that auto scaling group and it's going to contribute to hopefully bringing that metric down, the CPU utilization down. Let me go back into the auto scaling group again and let's just go in there We'll click on activity. Okay, and because, so let's just go into monitoring again, just show you what's going on. EC2. And because we're still going up on the CPU utilization for the average, what's actually happening is AWS is going ahead and launching another instance. Okay, so if we go back into activity, you will in fact see that it's gone ahead and now launching another instance. And it's doing this because obviously the average CPU utilization is not coming down yet, okay, because we're still running our stress test on this server. If I do a refresh on this page, you can see where we are with that particular CloudWatch metric, okay. And in fact, if we go into the actual EC2 instances, let's go up here again, okay. And this was the one that was having the stress on it. If we scroll down, you can see that that is all the way up to 70% now. Okay, so that's up to 70%. The CPU utilization across the board for the ASG, we can take a look at monitoring there for our EC2. Okay, currently around about 46.9%. Okay, so auto scaling is going on and deploying an additional instance in the hope that will bring it all down. Okay, right. So if I go up to instances again and I refresh that page, I've got a fourth instance that's come into the auto scaling group, hitting my maximum auto scaling group value, in the hope that we can get the overall CPU utilization down for that fleet. Okay, so I'll speed up the process. Let me just show you what's happening. So what I'm going to do is I'm going to go back to my EC2 instance and I'm going to break out of that stress test. Okay, essentially what I've just done is I've stopped the stress test from running on this server. Hopefully you would have guessed by now what's going to happen. If we go down to all alarms, okay, we've got a situation now where the alarm is okay, so it's coming down, okay, but the overall CPU metric, the average CPU metric across the fleet hasn't dropped below 22%, okay. So given the fact that I've now stopped the stress test on this server, for the server that's part of that auto scaling group, we should see a dramatic drop in consumption of CPU utilization. This will take a little bit of time to get registered, okay? And so I'll pause the video over here and then come back to it and show you the net results. Okay, back to my CloudWatch dashboard. What you will notice now is that in fact we have another alarm that's been triggered. Okay, we stopped the stress test on that particular server and that dramatically reduced the CPU consumption, or rather the CPU utilization. And so what you will see now is that in fact the opposite alarm has been triggered. The alarm which says that if CPU utilization is less than 21% for 15 data points within 15 minutes, then trigger this alarm. What does this alarm do? Well, basically this alarm is responsible for actually reducing the number of EC2 instances in order to fulfill that target tracking policy. Okay, so if we now look at the actual data points, you can see that in fact we're substantially lower, okay, than our 30% mark. And our auto scaling group was configured to ensure that we always had 2 servers running as minimum and desired capacity, and the maximum capacity was 4 if we needed it. But if we go into monitoring and click on EC2 there, then you will see that in fact CPU utilization is almost next to nothing. So if we now go into activity, you will see that auto scaling actually terminated 2 instances. Okay, so that one there and that one as well. And this was because it had to respond to a change in the desired versus actual capacity, shrinking the capacity from 4 to 3 and then 3 to 2 in order to fulfill the target tracking policy, okay, because it needs to fulfill that particular policy that was put in place. So if we go to our instances and if I refresh that page, there it is. I've got only 2 instances running, right, as opposed to 4, which was temporarily the case. Okay, so if we go back to our application, well, our application is still going to be running just fine. Okay, and we can switch between USEs 1A and 1B. Okay, so that pretty much brings us to the end of this video. Now, I strongly encourage you to actually carry out the lab exercises in your own AWS account, because building hands-on experience is absolutely vital for you to understand how the technology works. And I do have one request. Please like, subscribe, and share with your friends and colleagues. Thank you.